Welcome to the Octavo Systems booth here at Embedded World 2025. We're doing system and package solutions, and here we're going to show you one of our customer demos using the products.
Hi, so here at Octavo Systems, we do system and package. And what that means is that we integrate microprocessors with DDR memory, power management, and all of the passive components needed to integrate those into a molded BGA package.
And what is enabled with your guitar?
So what this is here is one of our customers' products. So this is a company called Chaos Audio, and using our system and package device, they were able to create this digital multi-effects pedal. So what this does is it connects via Bluetooth to a tablet or a mobile phone, and it allows you to build out a digital pedal board. So if you're familiar with guitars, you know that the traditional analog involves several different pedals across a large board, and this allows you to consolidate them all into one place. So what you can do here is it does real-time audio processing. So as you press these buttons, it translates to the guitar. So you can see before, it sounds like a clean, normal guitar with one button press. We have several different effects you can choose from if you want something heavier, and since we're in Germany, it seems right.
It's really cool. And is this unique, this kind of product, to enable something like that?
Yes, actually, the real-time audio processing has been something that's been a white whale for people in the audio community. So to have a device that's able to, in real time, apply the effects with no noticeable delay is quite an advantage.
And what's the advantage of working with Octavo Systems to do something like that?
So as Matt mentioned, these guys were basically right out of school. They had a lot of software knowledge and a lot of musical knowledge, but didn't have the hardware design knowledge. So basically what using this device allowed them to do is it allowed them to basically create their product. They've actually told us in a case study that they would not have been able to build this product without this, because again, they just could not handle the DDR routing and power management and all that kind of stuff. So if you actually open up their product, what you'll see is basically just a memory device, our device, Bluetooth, and then again, everything that they've done is really in the software side and doing that real-time audio. So it allows them to really focus on what they're good at and not have to learn a bunch of new skills that don't really add the value.
So do you help with time to market?
Time to market is a key thing, and actually if we want to go look at a great example of the time to market, we can come over to this guy over here. So this is another one of our a demo of another one of our customer products. These is Olive Robotics. They basically make a modular robotics kit. Cool thing about what they've done is they actually have these modular kits that are all based off of ROS. So they all run the robot operating system. And so what that means is they basically have a little Linux computer in each one of their nodes.
And it's following me?
Yes, it basically follows you around. It tracks people as it goes, and this is just the demo that we put together. But for these guys, they were a startup who had a lot of experience doing robotics design, hardware design, software design, and all that kind of stuff. And what they did, they looked at it as like, all right, we're trying to hit this small form factor. And if we really wanted to go do this, it's going to probably take us like 18 months of engineering to go make this happen. And being a startup pre-revenue, that was a long time for them. So what they did is they decided to use the system and package.
And it's right there.
And this is their servo board that goes inside each of these little servo units here. You basically have the Linux processor. This is based off of our OSD32MP1, which is based on the STM32MP1 microprocessor. So this runs Linux and ROS on it, and then basically on the A7s, and then they use the M4s to control the 4 servo motors around here instead of having one big one. But they basically were able to then build this instead of the 18 months that they expected it to take in only 3. So they were basically able to get to market 15 months earlier, over a year earlier, allowing them to get from no revenue to revenue that much faster, which is again huge for a startup company, and at them hit the size requirements as well that they had.
So what's the idea with system in package? And you're the world leaders for that?
Yeah, so system in package decades, but it's always been reserved for kind of the largest companies. So companies like Apple or big military companies or companies that have just created a set of standard commercial off-the-shelf product that is basically makes system and package available for everybody, allowing anybody to get to market faster and take advantage of the small size that system and package provides. So a great example of kind of the space savings that you see is our latest product based off of the AM62 from Texas Instruments. So this is our OSD 6.2 processor module. And what it does is it actually takes the AM62 quad-core A53 processor and pairs it up with 2 gigabytes of DDR4 memory and puts it all into a single device that is the size of basically a DDR package.
So it's right in there?
Yep, basically right in there. So if you look at kind of the system before, right, if you had to do your development, you were going to have your processor system and then your DDR, all this routing area and stuff like that. We've taken both of those and now put it in just the same space as that DDR memory. So that's basically a 70% space savings that you get with this device.
All right, that's so cool. But this is like multiple layers. How does it work?
So for this particular device, basically what we've done is our new product roadmap and our new architectures. We're doing now basically stacking of the components inside. So underneath you see the DDR or the processor module. Stacked on top is the die DDR that we get that we then wire bond down to the substrate. So we basically do all the design and everything like that in-house. And then
so maybe you can explain a little bit how it's done?
Yeah, I think that would be great for Eric, who's our CTO, to step in here and give you some of the technical details.
Right. So in terms of some of the integration that we do, basically we work with a lot of different processor families. So we have families from Texas Instruments, the AM335 family and the AM62 family, as well as processors from the ST, MP1 and MP2 families. And we also work with AMD and formerly Xilinx in order to do some of the Zinc UltraScale family of processors. And so really what we do is we look at this from a system point of view. We want to try to make sure that as a designer of an integrated system and an embedded system, that you have the easiest time possible in order to be able to take a processor and a memory and really integrate those into your final product. So we want to make your hardware life as easy as possible. We want to make your software life as easy as possible. And to do that, we take a look from a system point of view and we integrate some of the common types of things that you need for every system. Things that are table stakes to your design and don't really necessarily add any differentiated value. So we look at things like DDR memory. It's something that's difficult to integrate, but at the same time, every system has to have it. And so we look at things like that, at power management, and really make sure that we put those at the forefront of what we're trying to integrate into our system and package devices. Now, from kind of other design point of view, we look at how do we go about making sure that we can escape all these IOs effectively. And so we really enable things like 4-layer PCB design and low-cost design routing rules. So as you can see on our 6.2 product, we have one of our development boards. So basically, we have, so we have it running on the demo here, but you can see up close, this is one of our development boards for the OSD 6.2 family of products. This is a 4-layer PCB. It uses 3 mil trace, 3 mil space, 4 mil drill, and 10 mil vias, but it's a 4-layer PCB. It does not have via and pad. It does not use any blind or buried or micro vias, and it's a single-sided PCB. So there's much PCB simpler to make. Basically, no backside components are required in order to do this, and so you're able to have all of the different interfaces that you need and focus on what is the application requirements for your embedded product. So really, and all of Our hardware designs are open source, so you have access to full schematics. And then for most of our reference designs, you have access to the full layout, so you have a really good reference for how to go about looking at designing with these system and package devices.
So do you simplify the embedded world?
So we are really, that's the goal. At the end of the day, we want to make sure that your job as a hardware designer, as a software designer, is at the easiest that it can be. We all have to do more with less, and really system and package is one of the ways that we enable folks to be able to do more with less.
If we can go over there, maybe you can illustrate a little bit more of what we see on the whole design.
So basically what we do is we look at what are these components that are needed from a system point of view. So starting off with the different processor families, we then pair that up with high-speed memory. Originally, we would use some levels of packaged DDR, but as we have made more and more connections with different silicon providers, we now move to die DDR, which is what you see in the 6.2 family of devices. We look at, from a power management point of view, what is a good power management configuration for this given processor interface, and then we add things that are good for supporting the rest of the system. So potentially some LDOs or some other output power, so that way you have your 3.3, your 1.8 volt power rails that can power things on the rest of the system. Really, the whole system and package makes a microprocessor system look more like a microcontroller. Really, it's a single voltage rail input, and you're able to focus on all the things that can differentiate your design, as opposed to having to go through and do a lot of different work in terms of trying to manage all of these components.
And your company, you've been partnering with Texas Instruments for a long time, no?
Correct. We have worked with Texas Instruments for many years. Many of us are ex-TI employees, and actually our co-founder was the former principal fellow of TI. His name is Gene France. He helped be able to get DSP started with, and really DSP is what has led to the AI revolution. And so really you look at Gene France and his contributions to the industry as a whole, it's been phenomenal. And so when he retired from Texas Instruments, he decided that he wanted to look at what's the next generation of integration, and that's really at the package level. When you look at system on chip, basically you have to choose a process node, and in choosing a process node, you choose compromise. And because, like, for certain types of process nodes, you can do really not good processing in memory. Some process nodes are really good at power management. Other process nodes are really good at RF. But in order to get the best of all of those process node variations, you have to integrate them at a package level. And so system and package really can bring together the best of everything and start to get really small form factors for these types of systems.
So here we see some of the other ones. When you talk about DSP, it sounds like something like hardware acceleration, like performance.
Correct.
So you're totally involved in making the hardware acceleration, the performance great.
So we want to enable all of our customers. Choosing a processor is a very personal decision. Everyone has their own set of tools that they've grown up with. Everyone has their own set of things that they've wanted to do from a processor point of view and are comfortable with. And we want to make sure that there's a system and package to make your life easier for those given processor designs. We want you to have that comfort and that flexibility of being able to use the processor that you want, but then have a system and package that will go in and make sure that everything is nice and easy to use.
So maybe you can check the next demo right here. Maybe you can and explain. What do we see here?
Yeah, so this is one of our technology demos on one of our other product families. So we talked about the Texas Instruments device. We also work with STMicroelectronics. And then this is one of our Xilinx Zinc UltraScale Plus ZU3 based products.
Here?
Yeah, so this is basically the inside of the device. And what you can see here is basically what this is right here is what the customer would buy. So this is what you would get, basically an entire lidded package. And then this is what it looks like on the inside of that device.
So it looks like a fatter chip. a little bit, right?
It's a little thick chip and wide, but again, from a Xilinx FPGA type design system, it is still significantly smaller, 60 to 70% smaller than doing it yourself. And then what's really interesting about this is not just the size, but really the simplification. And this one really is a great example of how system and package can simplify your design, because with this kind of FPGA module, you're looking at basically 15 power rails plus the LPDDR4 interfacing. And with our integration, basically, we have now taken all those 15 power rails and put it all into one. So now from a design perspective, instead of having to route all that and figure out all that, you just do one 5-volt in, and then the device, we generate all the other power rails, and it just boots up, which allows you now to create basically 4-layer PCB. So this is our evaluation board, which is only 4 layers.
And it uses 5 mil trace, 5 mil space, so that way it's very low cost PCB design rules, so that way you can actually have the power of an FPGA with a really simple low cost printed circuit board.
So it's like a high performance FPGA. How about power considerations with your company? Does it make the cooling more complicated, or actually it's much better?
So basically what we do as part of our design process is really consider thermal management. And so basically within our substrate design, we are trying to do as much as possible to bring the heat down through and into the PCB. Now you're still, for things like our OSD ZU3, do need active cooling systems for most applications. But again, this is at or better than what you'd need for a discrete system in terms of being able to dissipate the thermal energy generated by the processor.
Do you enable a lot of startups or a lot of big established companies working with you?
We are pretty much working with everybody, right? We work from single entrepreneurs all the way up to the biggest global Fortune 500 companies. It's really about the team and what they're looking for. Again, really the speed to market that we provide by doing this is really something that is beneficial for companies of any size. And then because we use IC manufacturing technologies, we can really scale our volumes along with the most demanding applications. So whether you're trying to buy one device or millions of devices, we can supply that, we support that. And we really, one of the things that I think differentiates us, besides the technology, is actually the support that we provide. So from Octavo Systems, basically, our goal is to help you across every stage of your product development cycle, whether it's at the beginning, kind of research phase, design phase, development, prototype, even all the way into production, right? We've got decades of experience on both systems and IC design that basically we can help you and work with you all the way through. We really provide industry-leading support.
What does Octavo mean?
So,
what's it about?
So Octavo, the word itself, comes from the printing press and basically the innovation of being able to do a print on a page and then fold that into basically 8 pages. So what that did is it allowed you to significantly shrink the books, also significantly reduce the cost of them, and make printing basically available to the masses and books available to the masses. And that's the same concept that we have with system and package. Again, the founder, Gene France, has really thought about, and what we talked about, bringing system and package from the large companies to the masses and seeing what they're able. So that's the similarities there. So it's really about miniaturization and then making available to the masses.
Would you like to talk about this demo itself?
So we also work with a lot of third-party partners in order to be able to do a lot of development. So these are our development boards. So we have development boards around each of our different products. And then one of our fun demos is this product here integrates the processor, the high-speed memory, the power management, as well as eMMC. And so basically you have all the components for a complete Linux processor. And so this is actually a complete Linux computer that we've debugged on a piece of plexiglass. So all we had to do was connect up some wires for USB for power, as well as some communication. We have some LEDs to make sure everything works. And this is a full Linux computer that can run by itself.
It's a zero-layer Linux computer.
That's cool. All right. The only thing that's missing is to make the SiP disappear also. All right.
But yes, so we have a lot of different of our development boards, and then we work with a lot of different industry partners in order to be able to provide different types of solutions. So this industry partner, Idestrom, created the Torque Brain, which is basically an industrial torque wrench that uses the MP1 to do internet connectivity for this industrial torque wrench. This allows you to do tracking of what does each bolt experience as it's being torqued, as well as transfer that information up to the cloud so that way you have full accountability when you're building things like windmills or automotive cars and things like that.
Yeah, but again, this is another example of one of our design partners, and these guys have a lot of experience with hardware design and development and stuff, and they were just like, our value is being able to shrink things down. We don't want to do DDR and that kind of stuff, so they're like, let's use system in package, get into this form factor that we couldn't before, and let's not have to worry about DDR, let's get to market faster and stuff like that.
Yeah, and then we have partners like Pengutronics. Basically, this is a test automation controller that can talk over CAN or RS-485. It's powered by Power over Ethernet and can take in the various USB. And really, they enable a lot of automation using embedded Linux. And so they're one of our partners as well.
Yeah, and again, their focus is really embedded Linux and the software, right? The hardware design is a secondary thing for them. So again, they really like using our system in package because it allows them to do more a hardware type development without really having to get into the details of DDR and power management and stuff like that.
Because software is great, but the hardware is really cool, no? And when you help people to make the hardware, that opens up new doors.
Correct. And being able to do system in package really enables all of these new form factors that might not otherwise have been realizable when you have just discrete components. You're able to have something that's up to 70% smaller than what you would have with a discrete implementation. And that really enables all sorts of new ideas because you can put electronics in places where you might not have otherwise been able to put them in the past.
Yeah, again, opening it up to these, again, a thing that Gene has said is innovation is inversely proportional to the size of the company. And it's funny because he was, again, led innovation at Texas Instruments. But so his whole idea was what could happen if we put this technology in the hands of these smaller creative people, some of that. And again, it's been very interesting to see. So you get a lot of people now that have very little hardware knowledge, so very deep into software or even just an adjacent, like they know their industry very well. And so they're like, hey, what can I do with this to help my industry, and coming up with really brand new, innovative things all the time.
Even very big companies, it's my understanding that they try really hard to make smaller groups of people that try to innovate, and they could totally use this to try different things. And it's kind of like moonshots. Some of them become huge.
Right. Yeah, no, exactly. And that's kind of what I said across the board, whether it's one or huge Fortune 500 companies. Definitely as everybody tries to do more with less, move faster, get smaller teams, this is really a big benefit for them because, again, at the end of the day, nobody really cares if you got your processor module to work or not. They care about what you did with it. And so what this does, it allows you to just put this down and not worry about it, and then go ahead and spend your time on things that are really going to make a difference and differentiate your product and add value to your customer at the end of the day.
Right. Did you have a lot of good discussions here at the Embedded World?
Yes.
Oh yeah, the Embedded World is fantastic. We love coming here. We're based in the US in Texas, and so it's a great opportunity for us to come over and get to see and interact with a lot of our European customers. A lot of, again, really new, cool ideas, a lot of excitement around what we're doing. We really see the trend of modules and more modular use really permeating around the industry. Everybody's looking for modules. Again, how do we get things done faster with less resources? And then size and weight is also a big one, which is really where system and package kind of checks both of those boxes for them.
The new Silicon Valley is in Austin, right?
Yeah.
Yeah.
I mean, there's definitely a lot of stuff moving there, a lot of really good talent, a lot of really innovative companies in the area. So yeah, no, we feel good.
All right, thank you so much.
Excellent.
All right, thank you.